Alright, so some of you may want some practice, some extra practice. This exam is posted on Google Classroom, and these are the solutions to those exams, or that exam. So first of all, what I'm going to do is I'm just going to go through. I'm not going to do a whole lot of talking on this video. I'm just going to show you the answers, and then I'm going to go to some of my work and explain some of the answers. So number 1, these are the answers, and number 2, number 3, and then I'll show you that work in a minute. For number 4, to figure out the solutions for this one, what you have to do is you have to sort of look at each of the coordinates on this. You'll notice that this coordinate here is at -2, and then here it's -4. Here it's at 2, and then here it's at -2. So what you've done is you've subtracted 2 from each of the coordinates. Whereas on this one, notice the coordinate was at 2 and now it's at 4. It's at -2, now it's at -4. And so what you did this time is you multiplied each of the coordinates by 2. So it's 2 times the function. And then this one is an inverse function, so you've got it flipped over the x-axis. And so that's where you do the negative f of x. So look carefully at the coordinates for those to help you out better. For the 5th problem here, they wanted you to find f composed of g. So that means you're taking g and you're substituting it into f. That would be your solution. And again, I'll show you some work in a minute. Then they wanted you to find the inverse of f of x. So here's our inverse of f of x. Then they wanted you to graph this quadratic. So you could start off by finding the vertex. The vertex is down here. So you've got this point way down here. And then you could find the x-intercept and the y-intercept to use that to graph the best. Okay? So that was those are some of the answers. Here's number 7. It talks about dry erase markers, and the answer should be 10,000. For this next one, they wanted you to find the intercept. So you've already got the factored polynomial. So that means one of your roots is -1. One of your roots is 5/3. And then your other 2 roots are plus or minus 3. It's a power of 2, 3, 4, 5. So it's a power of 5. So you're going to go down on the left, and up on the right. Since the root at -1 is even, that means it's going to bounce at -1. So at -1 we have it bouncing. And the other 2 roots are odd, so it's going to go through at all those other roots. This is my y-intercept. My y-intercept is 0, 45, and I just got that by substituting 0 into each of those problems. Alright, and then we have find all the zeros exactly, so we had to do some factoring, put it in our calculator, and do synthetic division. Here we have a problem with the formula. It says T is the number of months that have passed since the lake was stocked with bass. How many bass are in the lake after the lake was stocked? And so it just gives you some information. I'll show you the work in a second. Here's a problem. Again, I've got logs on one side and not on the other. So I'm going to have to solve that problem. Sorry. Gotta move that down. Okay. This one, it's asking you to use interval notation to find, use interval notation to state the domain. So the domain of the black graph is going from -6 to -2. And then it's open at -2, so it goes from -2 to +6, and it's open at +6. And then the range is going to go from this point right here, which is -3, all the way up here to +5. Okay, and then they ask you to find f of -4. F of -4 is going to be down here at about -2. Where's the graph decreasing? So let me slide this up so you can see it better. Where's the graph decreasing? It shows you where it's decreasing from here to here. So from -6 to -3. And then again, it's decreasing from, that should be 1 to 3. So from 1 to 3, it's decreasing again. Okay. Then it says graph this function converted, but it's asking you to shift it to the left 3 and shift it down 4. So if you take these key points, like you take this point and you're going to go to the left 3 and you're going to go down 4 and you're going to get these new points. So take each of these key points and go to the left 3 and down 4 and you'll get your new points. Okay. Alright, determine whether the function's even or odd or neither. So remember, I'll show you the work in a second on that. So you're substituting in negative x for the x values to figure out whether it's even, odd, or neither. Find the horizontal, vertical, and slant asymptotes if any of the following. So there's no horizontal asymptote. There is no vertical asymptote in this case because if I factor the top, it'll cancel out. And no, I think my vertical asymptote, I'll have to go back and look at that. Let me look at my work really quick on that one. So number 14. So oh, here it is. I'll have to go back and look at that one for a second. So I'm going to say right now I've got no vertical asymptote on that. And then the slant asymptote is over here. Okay. And then we didn't do this last question, so you can skip that. So let's look at our work for this. Okay, this is the work for problem number 1. I'm not going to do a lot of explaining. I'm going to let you look at it and see if you can figure out what we did. Basically, we had to get a common denominator. So we went through and got a common denominator, and a common denominator was quite a bit of that fraction. Okay, for problem number 2, these are the problems where you need to get the 13 on the other side and then square both sides. Number 3, they told you that the triangle has a perimeter of 161, so perimeter is when you add up all 3 sides. This says the length of the 2 smaller sides is 2/3 the length of the longest side, so the 2 smaller sides are 2/3 the length of the longest side, and then we can combine all that together. Okay, number 4 I explained to you on the graph. Number 5, we talked about the composition of functions, so you substituted one into the other. And then to find the inverse, remember you switched your x's and y's and then squared both sides is what we needed to do on this problem, and then move the 7 and then divide by 5. So there's my inverse for this problem. Number 6, in order to do this best, I found my vertex. And so my vertex did come out to be some strange numbers, but that's all right. It's not a problem. So I got my vertex for the problem. And then to find my y-intercepts, I substituted in my a, b, and c into quadratic formula. And so I got my 2 y-intercepts are at 2/3 and -9/5, which is about 0.6 and -1.8. So that's how I got my y-intercepts for that problem, and then I used those 3 points to graph my line, my quadratic. Okay, so problem number 7, it was asking you to determine the profits made for this problem, and so again we're going to look at our vertex, and when we go through and find our vertex, we find out that x is 10,000. So 10,000 is going to be the highest or lowest point, in this case the highest point. And then when we substitute 10,000 into the problem, we get 2,999,000. So it means 10,000 are going to be sold for 2,999,000. Okay, so number 8 we already talked about. Number 9, we needed to find all the zeros exactly. And so I'd use my calculator, and I should see a root at 2, and that root is bouncing. So I'm going to do synthetic division twice with 2. Oh, no, it's not bouncing, I'm sorry. So it does not work when we do 2. So then once I got it down to this point, this is a quadratic. So I'm using my quadratic formula. And I come up with my other 2 solutions, which are imaginary numbers. Number 10 is a matter where we just had to substitute 12 in. I'm going to go back to that one real quick. We had to substitute 12 in for t and get an answer, so there really wasn't any other work for that one. Number 11. So number 11 is our log problem. So what I'm afraid this is a different log problem. So the log problem that you have on your paper is, let me make sure I've got the right one here. Yep. So this is a different log problem. So let me write down the log problem we have. So we have log base 2x plus log base 2x plus 7 equals 2. So what we have to do with this is make this into a product. So we're going to say log base 2x times 2x plus 7 equals 2. And then it's going to be 2 to the 2 to the 2nd power equals 2x squared plus 7x. And then I'm going to end up with 2x squared plus 7x minus 4 equals 0. And I'm going to either use quadratic formula or I'm going to use factoring to get that. So factoring 4 times 2 is 8. So 1 times 8 is 8 and 1 times 8 is 7. So let's see if that works. So we have 2x plus 8, and we have 2x minus 1. So we end up with x equals -4 and x equals 1/2. And -4 we're going to throw out because we can't use that one, so our only solution is x equals 1/2. So I just have the wrong log problem written over here. So that's your solution for number 11. Okay, and number 12. Actually, this is our number 11 right here. So here's number 11. Okay, so I must have had a different problem in there. Number 12 we talked about already. That was that problem that we had with the graph. There's our number 12 problem where we had the graph. Number 13. So we're checking for even and odd on this problem. So remember, you substitute -x in for our problem and you get -x to the 5th plus 4x squared. That's not the same. So it's not even. Then I set it equal to -y, and I reduce the problem, and I get x to the 5th minus 4x squared. So it's still not the same, so it's not odd either. So that means it's not odd or even, so it's neither. Okay. Alright, so here's our next one, and this is where we have the horizontal and vertical asymptotes. So our horizontal asymptotes, because the x squared is bigger than x, there's no horizontal asymptote. There is no horizontal asymptote. Okay. Our vertical asymptote should be let's check this really quick. So what I'm looking at here is that this can factor. So x squared minus 7x plus 6. And if I graph that, I believe one of my roots is going to be at -3/2. So let's look at our table settings and go -3/2. That's not right. Okay. Oh, I didn't mean to do that. So it looks like to find our